Hello students, welcome to Matrix Tutorials, a place for some exciting videos on physics, maths and computing. In this video tutorial, we are going to discuss indefinite integration for class 12, CBSE, ISC, other state boards and also for engineering entrances. This video tutorial will focus on integration by parts only. All these other topics will be covered in upcoming videos. So let us start. There are basically three techniques of integration: integration by substitution, integration by parts, and integration by partial fractions. Integration by parts is a method of integration which is used when the integral is a product of two functions like x sin x. You can see here this integral is a product of two functions, one is x and another is sin x. Similarly, x square and e to the power x, x and log x, x and sin inverse x, e to the power x cos x. Integration by parts is used generally when the integral is a product of two functions. One is called the first function, that is f of x, and another function is g dash of x, which is the derivative of a function g of x, called the second function. So there are two functions in integration by parts. One is the first function and another is the second function. If the integrand is in the form I equals to integration of f of x g dash of x dx, this is the first function and this is the second function, then we can evaluate this integration directly by using the formula given here. So the integration will be f of x g of x minus integration of f dash of x gx dx. When using integration by parts, we have to follow certain steps. The most important step is to identify or choose which of these two functions will be the first function f of x and which will be the second function, that is g dash of x. Once we choose these two functions correctly, then we proceed to next steps. Remember, a wrong choice will lead to a more complex integral which is eventually becomes impractical or impossible to evaluate. So right choice of the first function and the second function is the key to succeed in integration by parts problems. Once you select the first function and the second function, you have to differentiate the first function to find f dash of x and you have to integrate the second function to find g of x. Why these two functions are required? Because they appear in the formula of integration by parts. After finding the derivative of f of x, that is f dash of x, and g of x, after integrating g dash of x, use these values directly in this formula to evaluate the integration, that is this one. So choosing the first function and the second function is the key to use integration by parts. Then how to choose these two functions? The key is the first function f of x should be chosen so that its derivative f dash of x makes the integral simpler. Just you can see here, this is the first function and this is the second function. This function needs to be differentiated to give f dash of x, and this function should be integrable so that we can find g of x. So this integral splits into two parts, f of x gx minus f dash of x g of x dx. This integral should be simpler than this one, so that we can use integration by parts. And remember, the second function we have to integrate, so it must be easily integrable. Some integrals like log x or sine inverse x or tan inverse x don't contain a second function, so we take unity or 1 as the second function, that is log x is equal to 1 into log x, or sine inverse x is equal to 1 into sine inverse x. Integration by parts provides a guideline to select the first function. The order is elate. I stands for inverse trigonometric functions like sine inverse x, tan inverse x, cot inverse x, cos inverse x. L stands for logarithmic functions like log x, log square x, and like. A stands for algebraic functions like x to the power 3. T stands for trigonometric functions such as cos x and tan x. And E stands for exponential function, that is e to the power x. So the first function is chosen in this order, means if an integral contains two functions, choose the first function which appears in the list first. Means if there is x e to the power x, then choose x as the first function because it is a algebraic function, and e to the power x as the second function because it is an exponential function. And remember, this guideline don't always work. So let us see an illustration to learn how to use this elate guideline to select which should be the first function and which should be the second function. Our integral is x e to the power x dx. X is an algebraic function and e to the power x is an exponential function. In the order elate, x appears first because it is an algebraic function. E to the power x appears second because it is an exponential function. So our natural choice should be x as the first function and e to the power x as the second function. So let us take that one naturally. So let f of x is equal to x and g dash of x is equal to e to the power x. Differentiate the first function with respect to x, that gives us 1. Integrate e to the power x with dx, that gives us e to the power x. Once we get these values, put it in the formula of integration by parts. Now it becomes x e to the power x minus integration of e to the power x dx. Now we can see this one is simpler than this one. We can easily integrate the second term here, which is e to the power x itself. Now consider the contrary. If we take f of x as e to the power x and g dash of x is equal to x, then derive e to the power x, that will be e to the power x itself, and integrate x, that will be x square upon 2. So now after putting these values in the formula of integration by parts, the formula becomes x square e to the power x upon 2 minus 1 by 2, then integration of x to the power 2 e to the power x dx. Now you can see this integral is more complex than this one. We need to integrate it again by parts, again by parts, again by parts, and eventually it will be more complex, more complex, more complex, and quite impossible to evaluate this integral. So this is the natural choice, so we should stick to this. Let us see how these type of problems are solved using integration by parts. So the integral is x e to the power x. Let x be the first function, that is f of x. So f dash of x will be 1 because the derivative of x is 1 using the power rule. Similarly, let g dash of x is equal to e to the power x. This is the second function. We need to find g of x by integrating g dash of x, which will be e to the power x. Put these two values and also these two values in the formula of the integration. So the now integration becomes f of x g of x minus integration of f dash x gx dx. So f of x is x, g of x is e to the power x minus e to the power x dx. Now the integral of e to the power x is e to the power x. So our final integration will be x e to the power x minus e to the power x plus c, or if we take e to the power x common, it will be e to the power x whole into x minus 1 plus c, where c is an arbitrary constant of integration. So this is a simple example of how to use integration by parts. Take another example, e to the power x cos x. Here e to the power x is an exponential function and cos x is a trigonometric function. So according to the Euler formula or Euler guideline, trigonometric function comes first and exponential function comes later. So we can take trigonometric function as the first function or exponential function as the first function, because in integrals of this nature it does not matter which we are taking as the first one and which we are taking as the second one. Just see. Let us take e to the power x as the first function and cos x as the second function. So the derivative of e to the power x is e to the power x and the integration of cos x is sin x. Put these values in the integration formula. It gives us I equals e to the power x sin x minus integration of e to the power x sin x dx. Now you see, here the term is cos x, here the term is sin x. We need to evaluate this again using integration by parts. If we take the opposite, means we take cos x as the first function and e to the power x as the second function, the derivative of cos x is minus sin x and the integration of e to the power x is e to the power x. When we put these values in the integration formula, it gives us e to the power x cos x plus e to the power x sin x dx. Now this also needs to be integrated once again by using integration by parts. So integrals of this nature are required to be evaluated twice or more to find the final integral. So let us find the solution of this. Let e to the power x is the first function and cos x is the second function. So we find f dash of x is equal to e to the power x and gx is equal to sin x. By putting in the formula of integration by parts, we find e to the power x sin x minus integration of e to the power x sin x dx. We have to integrate this once again. Just stick to the choice, means in this one we had taken e to the power x as the first function. Just stick to that one, be consistent. So take e to the power x as the first function, so it gives f dash of x is equal to e to the power x. Take sin x as the second function, so g of x is evaluated to be minus cos x, because the integration of sin x is minus cos x. Now again we have to put these values in the formula of integration by parts, which gives us minus e to the power x cos x plus integration of e to the power x cos x dx. Now just watch this one. It was the original integral we are given. So when we put the value of this one here, we find e to the power x sin x minus e to the power x cos x plus integration of e to the power x cos x dx. When we open the bracket, we find e to the power x sin x plus e to the power cos x minus of this, which is our original integral. So take this minus I to the left side, which gives us 2y equals e to the power x sin x plus e to the power x cos x, or I is half of e to the power x sin x plus e to the power cos x plus c, where c is the constant of integration. You can further simplify this by taking e to the power x out common here. So it will be e to the power x upon 2 whole into sin x plus cos x. So this is how integration of this type are solved using integration by parts. Take another example, log x dx. Here log x is a single function only which cannot be integrated directly. So multiply unit here. So this gives us 1 dot log x dx. Here 1 is an algebraic function. In fact, it is a constant function. So it can be categorized as an algebraic function, and L is an exponential function. So in the order of elect, logarithmic function comes first. So take log x as the first function and 1 as the second function. We cannot take log x as the second function because it is not integrable. Similarly, take the example of sin inverse x dx. Here again sin inverse x cannot be integrated directly, so multiply it with 1. Again 1 will be chosen as the as the second function, and sin inverse x as the first function, because first appears inverse trigonometric function, that is I, then comes algebraic function a. So now in these type of integrals, multiply 1 as the unity as the second function and take it as the second function because 1 is easily integrable. Don't take log x or sin inverse x as the second function because these functions cannot be integrated directly. So let us find the solution of this integral. As you see, we have taken log x as the first function, and we should. So f dash of x will be 1 upon x. Similarly, take 1 as the second function, so g of x will be integration of 1, that is x. So put these values in the formula of integration by parts. We get x log x minus 1 upon x dx. Here this x and this x both cancel each other, so the remaining integrand will be minus 1 dx. So the answer will be x log x minus x plus c. Again you can take x common here, so the answer will be x whole into log x minus 1 plus c, where c is an arbitrary constant. We will discuss further examples on integration by parts in a later video. This much is for today. Thank you for watching my video. Please like and subscribe my YouTube channel for more videos, and also comment. Thank you. Have a nice day.